Last week, after a long search online, you finally found the perfect gift for someone who is having a significant birthday. Excited, you clicked to add it to your shopping cart, only for the app to tell you that you can't because the item is out of stock. Now you have to find a different present. What a disappointment! But imagine if the ordering system didn't check that the item was in stock and let you complete the order. It might have been some time before you discovered that your carefully chosen gift wasn't available. Perhaps you might not have discovered it until it was too late to order something else. So how does the program handle your request in this situation? When you try to order an item that doesn't exist, you are attempting to perform an invalid operation. Similar situations can occur in programming, and they could cause exceptional behavior. Let's examine some of them. Mistakes do happen while writing code. Just as you end up getting things wrong in your day-to-day work, when writing code, you might end up doing the same. Mistakes in code can lead to unchecked exceptions. So what exactly are unchecked exceptions? Imagine you are writing code that has to divide one value by another when the program is run. That seems simple enough, you think. But what if you haven't allowed for the fact that one of the values could potentially change to 0? Division by 0 results in infinity. Obviously, infinity isn't a thing that can be represented in Java. When you attempt to perform a division by 0 calculation in a program, the Java runtime complains that it is not a valid operation. Developers can unknowingly introduce this and other similar mistakes into their code. Even minor programming mistakes can bring an application to a standstill by causing exceptions. The exceptions caused by such programming mistakes are known as unchecked exceptions. This is because the Java compiler doesn't check your code for these types of mistakes. Instead, it relies on you, the developer, to not make errors in the code. However, the Java runtime detects them and raises exceptions when you run the program. This causes your program to crash or break. This is why these exceptions are also known as runtime exceptions. Checked exceptions can be caught, declared, or thrown from code using the throws keyword which you learned about in a previous reading. However, the throws keyword is not meant to be used for unchecked or runtime exceptions. These exceptions are ideally meant to be prevented by developers with mindful coding and thorough testing. In Java, runtime exceptions are grouped into a hierarchy of classes. The runtime exception class is a subclass of the java.lang.exception class. It includes all the possible exception types that can occur at runtime. This means it is the parent or the superclass of all the different subclass types of runtime exceptions. Subclass types that represent common mistakes in code are arithmetic exception, null pointer exception, and finally, array index out-of-bounds exception. Now let's explore how these particular types of unchecked exceptions could occur in your code. An arithmetic exception occurs when an arithmetic operation results in an exceptional situation. Remember that divide by 0 scenario discussed earlier. Let's observe how that would create an exceptional situation. Create a new Java class named UncheckedExceptions1. Add a main method. In the main method, add code to divide 100 by 0 as int number equals 100 divided by 0. Nothing seems to be wrong here. The compiler doesn't complain about anything. Now run it. An exception is displayed in the console, indicating that an arithmetic exception has occurred in the main method due to a division by 0. In that example, you might have thought that the exception was obvious. However, imagine working with a large program that has many lines of code with many methods. In that situation, it could be difficult to spot this type of calculation error. Another type of unchecked exception is the null pointer exception. In Java, there are two kinds of memory, the stack and the heap. All variables that you create in your Java program are stored in stack memory. The heap memory is a special area of memory that stores objects. Variables can have a data type that could be primitive or non-primitive, which is also known as reference. A variable that has a reference data type would have an object as its value. Put simply, this means that the variable is referring to or pointing to an object. But what if it is pointing to something that is empty? If you try to access an empty reference variable and perform some operation on it, the Java runtime complains with a null pointer exception. This is like the ordering system telling you that the gift you tried to add to the cart is not in stock. This is how it really happens in your code. Create a new class named Unchecked Exceptions to. Add a main method to it. In it, create a string type variable called name. In Java, strings are treated as objects. So a string is essentially a reference data type. At runtime, the variable name is stored in stack memory. Assign a null value to it. This means that the variable name in stack memory is pointing to nothing in heap memory. In other words, it's empty. Now access the string and print its length by calling its length method. Run the code. Notice that there is a null pointer exception. This has happened because the string is null and doesn't point to anything. When coding with Java, it's important to remember that you simply cannot perform any operation on a string that's null. This video has explored and demonstrated the action of unchecked exceptions in your code. You now know that they exist to prevent unexpected behavior in your Java application due to programming errors or mistakes. This knowledge provides a strong foundation for how you will design your code. As you move on in your software developer career, you will gain experience and expertise in designing foolproof and effective code.